Setting up the job now. I'm going to give it a name, demo, and a description, which is just demo, and I'm going to hit OK. And the instrument will then go through some pre-diagnostic tests. So first it's going to pressurize the solvent bottles to make sure there are no leaks. And then once it passes that test, it'll move on to test the test syringe for any leaks. So what you hear now is the air pump that is simply pressurizing the solvent bottles. And then it will cut off and then monitor for any leaks. And it does that by measuring the pressure difference from start to finish. And so these are all really important steps in order to get consistent and repeatable data from your measurements. So it's passed, and it's now going to test to see if there are any leaks here in the syringe area of the instrument. And now this is really important because a key feature of the VROC initium is sample retrieval. So if you load your sample with, say, 50 microliters of your precious protein sample, and you begin running your experiment, and it requires more than 50 microliters of sample to be able to measure the range of shear rates you're looking at. What the initium does is it pressurizes the air into the chip, and the pusher block and syringe will then draw back about 45 microliters of your sample. So now you can run another test at a different shear rate or what have you, basically on until infinity. And we'll see this later in the test, but it's really important to make sure there are no air leaks in here before you run your measurements, because otherwise you won't be able to use that feature. And this is done before every measurement you perform on the initium. So now it passed the syringe pressure test, and so we're now moving on to the flow rate test, and here the instrument is pumping air through the chip to see how the pressure sensors are working. And so it will tell you if the chip is working properly and also tell you if your flow rates are in the correct range. And so now that test is passed, and we're moving on to the final flow test, which is testing the flow in this direction. So once that is all done, the instrument will move on to loading the sample and performing tests. Alright, so now that the pre-run diagnostics are done, the autosampler will now first test to make sure that it's calibrated appropriately. And now it'll move to the first sample, and it's set to pre-pressurization. So it pumps air into the vial, and it will now begin drawing up sample. And so it's automatically drawing the sample. Here I have it set to draw about 73 microliters. And so it's slowly drawing up sample so that no bubbles are introduced into the test syringe, because bubbles can lead to artifacts in the data. So it draws very slowly so that no large bubbles are introduced. Now it's done loading the sample into the auto sampler syringe, and it's now moving into the injection port to load the sample into the test syringe. And again, it is slowly pushing the sample into the test syringe so that bubbles aren't introduced into the closed system of the VROC initium. And normally this would be the point where you could get up and walk away and start doing your other experiments or taking care of paperwork or what have you, since now this instrument is completely running on its own. Now that it's sensed that it has injected all the liquid into the sample. So now the pusher block is moving to push the piston of the test syringe past the opening in the injection port, so that it is now completely sealed off to the outside world. And now the auto sampler removes this auto sampler syringe from the injection port, and now brings it over here to to the wash port, where the auto sampler syringe will now begin the cleaning process. So now the auto sampler syringe has been injected into the wash port, and now the auto sampler syringe is being cleaned. And this is all happening at the same time that data is being collected. So now the experiment is being performed. So the instrument is now starting to collect data from the sample that we've loaded. Pusher block is now pushing or priming the chip with the sample. So it's being pushed forward, and the fluid is being introduced into the flow channel of the microfluidic chip. And since we do not know the viscosity of our protein samples here, we've decided to run the instrument on automatic mode, which is a preset program that we provide here at RioSense to you, the customer. And here we'll determine which flow rate to run the sample and how to load the sample and all that important information so that you don't have to worry about that. This is a pretty straightforward and basic experiment. And the first segment of any run is called the priming segment, which is just the step where the test syringe and pusher block pushes the sample into the microfluidic chip so that the entirety of the flow channel within the chip is wetted. And so that first segment or that first measurement is always thrown out because it's the priming step of the chip, and so the viscosity measurements aren't at a steady state. So once the first segment is done, then the instrument begins taking viscosity measurements that you can use. So now the auto sampler has finished cleaning and is going to be in rest here until we move on to the next sample.